All right, class. So, like I said in the last video, this one is going to be really strict on, or you got to pay close attention to the rules. So, on this problem, on number 2, it is giving us some definitions of a Hamiltonian path. Okay, so a path on a graph that goes through each vertex once is called the Hamiltonian path. So it's strictly about the vertexes here. All right, so Euler was about the edges. Okay, so some differences there. Okay, a path that starts and stops at the same vertex and goes through each vertex once is called the Hamiltonian circuit. So again, starts and finishes at the same place through every vertex. Which of the following graphs have Hamiltonian circuits? And did some attempts, but here I'll put my solutions to this. All right, so let's look at this first graph one. Okay, so what I did, went this way. Okay, one, second path, my third path, and then of course my fourth path. Alright, this one did make a Hamiltonian circuit, so I'm going to put HC for Hamiltonian circuit. Alright, so when we talk about a Hamiltonian circuit, okay, I'm going to abbreviate that HC. Okay, on graph 2, alright, has a little weird curvy edge, so remember edges have no distinction on being straight or curved. Alright, so again, went this way, 1, alright, down to 2, this one's 3, and this one is 4. Okay, oops, excuse me, I'm gonna make this better. 4. Okay, so I did what was required here in graph 2. I got all the vertices and ended up back where I started. So this one is also a Hamiltonian circuit. Alright, notice I didn't use any of the edges. I didn't use this edge. I didn't use this curved edge. I didn't have to. I could have done other paths and gotten a circuit as well and been just fine. So you don't have to use all the edges for a Hamiltonian circuit. Okay, the key is the vertices. Alright, let's look at graph 3. Alright, so on this one, there is no path. No circuit, but I can make a path. Alright, so let's see. Let's go this way. 1, 2, 3. Coming here is 4. That way 5, 6, 7, 8, and that's it. Okay. I got all the vertices. Alright, so again, started here, finished there. Okay, but trying to end up back where I started, that is tricky. You can't do it on this picture here. So think about why that might be. So remember in the Euler lesson we talked about there being an even or odd number of degrees to the vertices, right? So that way you could tell if it was a circuit or not. So if all the degrees were even, okay, it was a circuit. You can make a circuit exist. If they were odd, you couldn't make a circuit. All right, so let's see if Hamiltonian works that way. All right, so in this one, no circuit exists, but there is a Hamiltonian path getting all the vertices here. Okay, graph 4. This one is a circuit as well. All right, here's a possible solution. One that way, one this way for 2. Going up here, that's 3. This way, 4, 5, and 6. Start and finished at that spot. Okay, so there are your Hamiltonian circuits and a path, possible solutions. You may have gotten this different solution, that's fine. But there you go.